Okay, beside that, another important formula that you have to know is data and star conversion formula. Okay, so data to star, okay, conversion. So your ZA, okay, ZC, ZA, ZB, and ZC is the data loads. Okay, and Z1, Z2, and Z3 is the star load. Okay, to convert, okay, the data to star load. Okay, so this is the formula. Z1 is equal to ZB, ZC divided by Z, the summation of ZA plus ZB and ZC. And Z2 is ZC divided by ZA divided by the summation of the loads. Okay, and then Z3 is ZA times ZB, okay, and divided by the summation of all loads. Okay, for star to data connection, okay, the ZA is Z1, Z2 plus Z2, Z3 plus Z3, Z1 divided by is Z1. Okay, the opposite of the load. Okay, ZB, okay, Z1, Z2 plus Z2, Z3 plus Z3, Z1 divided by, okay, the opposite of ZB is Z2. Okay, so ZC is Z1, Z2 plus Z2, Z3 plus Z3, Z1 divided by Z3. Okay, the opposite of ZC is Z3. Okay, so don't worry. Okay, so this formula will be given inside your examination. Okay, so this is, okay, the example 7. Okay, so you can see here. Okay, so you have the star to data connection. Okay, star to data connection. Okay, the V line at the generator is 208 with 0 degree, and determine the line voltages at loads. Okay, so what different between this and the previous one, the previous example? Okay, so if you see here, okay, in the previous example, your transmission line have no impedance at all. Okay, but for these examples, okay, they are considering the impedance through the transmission line. Okay, so the approach in solving this kind of problems is quite different. Okay. Okay, the solution for this kind of questions, okay, is just following the several steps that I stated here. Okay, so this is a generator side, this is a line side, and this is the load part. Okay, so find the line voltages at loads. Okay, so now the VAB no longer equal to EAB. Okay, VAB is the voltage, okay, at the load is not the same as the EAN, okay, at the voltage across the generator for phase A, because you have the drop in the line impedance here. Okay, so since the generator is star connected while the load is in delta connected, so thus following the step, okay, following the step here. Okay, so first step, okay, step 1, find the single phase equivalent circuit. Okay, since your load are in, okay, your load are in data connection, you have to do the data to star conversion. Okay, so since the load are in balanced load, okay, so the star connection is equivalent to Z data divided by 3. Okay, so Z data is 9 plus J 12 divided by 3. So you will get in star connection because they are in balance. They are, okay, they are balanced load condition. Okay, so the ZY, okay, is 3 plus J 4. So now remember that your loads are in star connected. Okay. So find the single phase at generator. Okay. So we know that, okay, your generator are in star connection. Okay, so phase, okay, the line connection, the line voltage is 208. So the phase in star connection, okay, is line divided by square root 3. Okay, we know that the star connection, the V phase is V line divided by square root 3. Okay, and then we put your EN as reference with 0 degree. Okay, so draw the single, okay, the second step, okay, after finding, okay, your EN, okay, so draw the single phase equivalent circuits. Since the load side was converted to star connection now. So use AN as reference. So this is your phase, okay, phase voltage for generator. So this is your line impedance. So this is your load impedance. Okay, and then the next step, find the phase voltage of the load using the voltage divider rules. Okay, so okay, the question want you, okay, to find this V phase of the load, voltage of phase voltage of the load. So is VAN. Okay, so we know that the Z, okay, is 3 plus J4. Okay, okay, because your load now is star, right? So when we convert from the data, okay, so it becomes 3 plus J4. Okay, so 3 plus J4 divided by, okay, the summation of the Z line plus with Z load. Okay, which equivalent to 3.1 plus J4.1 times with your, okay, voltage here, right? To get this voltage. Okay, times with your supply voltage. We consider this is as supply voltage. Okay, so which equivalent to 117 with 0.22 degree. Okay, after finding the phase voltage, so because we are here, okay, is the equivalent single phase voltage. Okay, by taking, okay, your ENN or your phase A as your reference. Okay, we just consider only one phase, okay, for the single phase circuits. Okay, so your VN, okay, the phase voltage, okay, for at the load side, okay, is equivalent to 117 volt, okay, with 0.22 degree angle. Okay, so the next step, okay, we find the line voltage of the load. So the line voltage of the load, VAB, okay, is square root 3, okay, VAN, square root 3 times with your V phase, okay, your V phase here is VNN, okay, the angle is 30, 0 plus 30 degree, okay, sorry, it's not 0 by 30 degree, but your angle is 0.22, okay, degree, okay, plus with 30 degree. So the magnitude is 203 and the angle is 30.22 degree angle. Okay. So this is generally, okay, the step in order you to find the line voltage. So we are using the star connection because your load now, okay, we are convert into from data to star connection. Okay. However, we have to consider all the several steps that I stated here because you have the line impedance here. Okay. So now, okay, I thank you. Okay, until we meet to the next part of chapter. So thank you for listening.